Hello all, I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore, and today we are going to discuss about series parallel and series parallel circuits. Okay, first of all, we are going to discuss about the basic elements of circuits. Here, an electric circuit, it provides a complete path for current to flow. We know that very well. And a basic circuit, it must include a battery, a power source, complete path, wires, load. Load means resistor, light, motor, like that. See here, many circuits which includes control devices like switch, protective devices, fuse, circuit breakers, like that. And see the diagram. What components does the circuit below includes? Okay, see, it includes a load, path, source and control. See, types of circuits. Circuits with multiple loads can be placed into one of three categories. And the types are series and parallel. See, these are based on the paths of current flow through the circuit. The first one is series circuit. It allows current to flow through one path from negative through the loads. Current only has one way to go from one side of the power source to the other side. See the diagram, it has power source and resistors R1, R2 and R3. Here the long line it indicates positive and in the down the short line is negative. See the current flow direction. Series circuits only allow current to flow from one path negative through the loads. It allows only one path from negative. See the current flow through R3, R2 and R1. Next one is parallel circuits. See here, parallel circuits allows current to take multiple paths from negative to positive through the loads. See, current can flow different routes from the source and through the loads and back to the source. It follows different routes. See the diagram. It has power source, resistors R1, R2 and R3. See the current flow. See, it has through R1, it has one route. Through R2, another route. And third route is through R3. It follow different routes. Next one is series parallel circuits. It contains areas of both series and parallel circuits. Some sections allow multiple paths for current flow. Other areas only allow one path for current flow. But it must have at least three loads to make series parallel circuits. See the diagram. Voltage source R1, R2, R3 and R4. See the current flow. First one is series and the second one is are parallel. Okay, resistance calculation is an important thing in series parallel connection because some circuits allow current to flow multiple paths. Current divides among these paths. This reduces the total current of these sections. Therefore, different resistance formulas must be used for different circuits. See, here we know that series circuit calculations, the current flow through only one path. The total resistance is equal to the sum of all the individual resistance. The formula is RT is your total resistance, which is equal to R1 plus R2 plus R3. Consider R1 is 10 ohm, R2 is 20 ohm, R3 is 30 ohm. See the diagram and you will get RT equal to R1 plus R2 plus R3. Your final answer is 10 plus 20 plus 30. So RT which is equal to 60 ohm. Next, parallel circuit calculations. See, it allows current to flow multiple paths and the current to follow multiple paths. Current divides among paths. Here the total resistance is always less than smallest resistor. Here the resistance formula is RT which is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. This is known as reciprocal formula. Here C R1 is 10 ohm, R2 is 20 and R3 is 30. Here your RT value is substitute all the R1, R2, R3 values in the above RT formula, we will get the value RT, which is equal to 5.45 ohms. Next one is parallel circuit calculation. Only two resistors. If only two resistors are in parallel, then we'll also calculate total resistance by using the formula RT equal to R1 multiplied with R2 divided by R1 plus R2. Here the total resistance is always less than the smallest resistor. Substitute R1, R2 values in RT. We will get the RT value as 10 ohms. See, parallel circuit calculations, all resistors are the same. Here, RT equal to R by N. N is number of resistors or loads. Total resistance is always less than smallest resistor. Substitute these values, we will get 10 ohms because all the resistors are same here. Series parallel circuit calculation, it contains both series and parallel elements. Must use series and parallel formulas. First determine parallel R value, then add to series sections. Here same, R1 is 10 ohm, R2 is 10 ohm, R3 is 10 ohm and R4 is 10 ohm. The formula RT, which is equal to R1, R2 divided by R1 plus R2. Substitute the values, we will get RT as 25 ohms. And here I have included the resistance formula flowchart, calculating total resistance flowchart. You can refer it. First we have to identify the type of circuit, and again we'll identify series, parallel, whether it is series, combination of series and parallel. Again we'll go to the formulas of series, parallel and series, parallel, and finally we will determine the perfect formula for our circuit. Okay, here I have included some problems. First one, see the diagram. What kind of circuit is it? What formula can be used? And what is the total resistance? See here, it is a series circuit. Formula is RT equal to R1 plus R2 plus R3. And our answer is RT, which is equal to 150 ohms. See the second one. See the second circuit. What kind of circuit is it? It is a parallel circuit. Here the formula is RT, which is equal to R1 R2 by R1 plus R2. And the total resistance is RT, which is equal to 6.67 ohms. And see the third one. What kind of circuit is? It is a combination of series and parallel. The formula is R1 R2 by R1 plus R2 and RT, which is equal to R1 plus R2 plus R3. See the total resistance. The total resistance value is 12.4 ohms. Thank you.